Things are not always quite as they seem when you go to solve equations, and here are two strange cases that demonstrate that. For the first one, we have 14x plus 7 equals 7 times quantity 2x plus 1. Okay, everything looks fine to me so far. Let's see. We distribute the 7 through to both those terms. All right, so 14x plus 7 equals 14x plus 7. And maybe here you can already realize that something's a little odd, right? Yeah, okay, 14x plus 7 does equal 14x plus 7, but let's continue on the standard practice of getting the x's on one side, everything else on the other. Okay, so I don't know, let's get the x's on the left. So we'll subtract off 14x, subtract off 14x. Well, that's weird, it just cancels out. So 0 plus 7 equals 7. Now let's subtract off the 7. That gives 0 equals 0. All right, so when you get something like this, it doesn't have to be 0. It could be, 5 equals 5, 100 equals 100. It doesn't matter. When you have something that's true no matter what, right? Yes, 0 equals 0, and notice there's nowhere to even put in an x. This doesn't care what x is at all, right? It just says, hey, 0 equals 0. This is true. This is true no matter what. Vacuously true, we could say. When you have a situation like this that is true completely independent of x, that means anything you could plug in for x will be a solution to this. I could plug in 50, I could plug in a million, I could plug in 1/2 or -5. All of those are going to give us a correct answer. So we want to include every possible value for x in this solution set. All right, so let's do that. There's a few ways you can write the answer to this. You can say something like this: all real numbers. That's one way. That's kind of the long way of writing it out. Maybe you like interval notation here, so you could say, okay, -infinity to infinity. That's another way of writing that answer. Or you could use this kind of fancy R here. This fancy R is a shorthand for saying all real numbers. So all three of these answers would be okay for this situation. All right, let's look at the other strange case. Okay, so here's another strange case. Everything looks okay, initially at least. 3x minus 7 equals 3 times quantity x plus 1. Looks fine to me. Let's see. All right, so we distribute this 3 through to both of those. That's our distributive property. No problem. 3x minus 7 equals 3x plus 3. Okay, let's get all the x's on one side. I'm going to get them on the left side, so I'm going to subtract off 3x from both sides. Well, there go our x's. 3x minus 3x is 0, so this is already looking a little odd. It's never a good sign when your variable completely drops out. Let's continue on. Let's add 7 to both sides. That gives us 0 equals 10. Okay, so in the previous case we had something that was true no matter what. This is false independently of x. False, right? No matter what we plug in for x, the x drops out, and this statement is false, and no x that we could plug in for this is going to save this equation from being false. There are no solutions to that. And since there are no solutions, we literally write no solution. Okay, that's one way to write the answer to this. Right? Another thing you could do is write what we call the empty set. Okay, it's like a circle with a line through it. This thing here, empty set, it's the set. It's a set with nothing in it. So we'd say, okay, we're going to here list a set of all the solutions to this. Oh, look, there's nothing in it at all. So that's another way of saying there is no solution to this equation.